All right, so welcome back. This will be from question 11 through 20. I'm gonna try to find the finish the middle portion of the multiple choice calculator section. So let's get right to it. Number 11 says, let f be the function defined by f of x equals square root of absolute value of x minus 2 for all values of x. The first thing that really just catches my eye is how kind of weird is this function is. Like I can't really visualize this. So let's graph it. You know, we can use the graphing calculator. So let's pull this out. Well, actually, that's not what I wanted to do. Oh, try this again. Okay. All right. Hopefully they have this saved somewhere. Okay. It's sorry. All right, so there we go. I'm going to graph this, the function that's provided for us here. It says y is equal to. Okay, so I guess I can't really zoom out anything further than that. But so y is equal to the, so square root of mass of x. Oh, sorry, the absolute value, which you can find it in math, and you go scroll right one to numbers. And so then that is going to be that x. Sorry, I'm going all over the place right now. X minus 2. And then you press graph for that. And then you get this weird looking shape that looks like, I don't know, one of those like kindergarten bird shaped drawings that they do. So at x equals 2, what you notice is that there's this little teeny tiny thing called like a cusp, where it kind of, it's not like a smooth, like a curvature. It's kind of like you go dip once and then you just spring right back out there. Now the limit certainly exists at those particular locations, but what you must remember is that at the cusp location, there's not gonna, you cannot differentiate as anything called cusp, okay? So that's spelled C-U-S-P, and at C-U-S-P, no differentiation. That's what you want to remember. So at x equals 2, it's certainly continuous. F is differentiable with x equals 2. That's certainly not true. F is continuous but not differentiable. That's what you want to say. Because certainly it is continuous. You can draw the graph from left to right without letting go of your pencil, but you cannot differentiate that. Okay. Number 12, using the substitution u is equal to square root of x. We usually call the u sub method e to the power of square root of x over square root of x dx. When you're using u sub, you need to first call u as square root of x, but then you need to derive that in terms of x to find out what actually du is. Square root of x is the same thing as saying x to the power of 1/2. So if you derive that using the power rule, you should get 1/2 x to the power of -1/2. You move the exponent to the front, you subtract 1 from the exponent to get -1/2. But then that also means that you have a dx right there. So applying this, actually using the square root symbol, negative exponent means that you have to put that variable in the denominator. So it becomes 1/2. And this right here becomes actually 1 square root of x like that, dx. So putting that together, okay, so du is equal to this. Putting that together, we want to find out what I need to substitute in for this function right here, which says like square root of x to the denominator, and it says dx at the top, right? If you get rid of this 1/2 then, because this is the component that I can actually substitute it in for that. We're going to move the 1/2 to the other side and say, I'm going to multiply that by 2 and cancel this out and just get this. So then 2 du actually equals to 1 square root of x times dx. Now, why do we want to go through all that trouble is because now I can substitute the 1 square root of x dx as 2 du. So that is actually what you're going to use to replace this portion right here that I'm highlighting for you in blue. That entire thing is just going to turn into du. And this right here is just going to turn into u because square root of x is just u. Okay. So in all of your answer choices, what you will see is that e to the power of u du is going to stay put. The one thing that you do have to worry about, though, is then what happens to these values that's 1 and 4. Okay, so let's kind of substitute all that in together and get what the final answer is going to be. So by substituting the 2 du in place of that, what I'm going to get is integration of e to the power of u times 2 du. I need to have the 2 in there because this entire thing is represented with 2 du. So anything without this double portion, I'm going to erase, which is d and e. They don't have the little 2 in there. What you will notice in part answer choice A, B, and C, they all have that coefficient 2 outside of it, right? Which is also one of those properties of integration. Any constant inside the integration, you can actually bring outside of the integration. All right, so what happens to the values? Well, these values to start and finish, they were values of x, 1 and 4, but now we want to get that in terms of u. Remember, u is equal to square root of x. The x was from 1 to 4. So what that means is you want to plug in your highest and the lowest boundaries and get the highest and lowest boundary for u as well. So when x was 1, u is equal to square root of 1. When x equals 4, u is equal to square root of 4. Well, that would be 1 and this would be 2. So your boundaries for u is actually from 1 to the positive 2 here. So what that would mean is the answer would be C, because we want to get the boundaries to be from here to here. Okay. All right, number 13, the function f is defined by f of x is equal to 2. That is when x is less than 3 and x minus 1 when for x is greater than or equal to 3. So this is like a piecewise function. They have 2 functions into 1. What is the value of the antiderivative integration from 1 to 5? The best way to kind of imagine this is for you guys to kind of draw a graph of this one. All right, so I'm going to draw an XY grid here. And notice that I'm going to start from 1, 2, 3, 4, 5, because I'm trying to integrate this from 1 to 5. When x is from 1 to 3, because it's you're following the functions for the first one, the y value is actually ending up at the 2. When x is from 3 and above, you do this like x minus 1 graph, where you plug in x as 3 because that's where your starting value is. Well, 3 minus 1, that's the function. And when f of 3, that's 3 minus 1, which is at 2. So when x is 3, y value is 2, and your slope is 1. So it's going to constantly increase by a format of rise over 1 by 1. So this is the graph that you want to get. Trying to find the area under this curve. I mean, it looks like a boot laid sideways, and you're trying to just find out the area by probably just using geometry more likely. So this is the area of a rectangle, which is the length is 4 and the height is 2. So 4 times 2 is 8 because length times height. This is a triangle. This base is 2 and the height here should be 4. I'm sorry. Well, the highest value of this reaches up to 4. So the value, sorry, I'm gonna just try to make this a little bit cleaner than to do. So that's 3, that's 4. So the value of this height should be a 2. So to find the area of a triangle, it's 1/2 base times height, 1/2 times 2 times 2, which means it's going to be a 2. And when you sum them up, 8 plus 2, that gives me a 10 for my final answer. Okay. All right, number 14. If f of x is square root of x squared minus 4 and g of x is 3x minus 2, then the derivative of the composite function, as we like to call it, composite means a function within a function inside of it. You're simply taking g of x and plugging into the place of x right there. So that would be 3x minus 2 squared minus 4, and you square root that. Remember, this is the function g of x that you're replacing it for x right there. The rest of it is pretty much the same as f of x. Then you want to take the derivative of this. Okay, so how in the world am I supposed to take the derivative of that? Well, you don't have to. Let's rely on our calculators, right? I mean, calculators allows us to calculate the derivatives and antiderivatives quite easily. You want to go to math. and you want to take the n deriv as number 8, and this is quite neat. I am going to use x, and I am going to type in the function that's provided for us right there, square root of 3x minus 2 squared minus 4. Ooh, that's my fault. Minus 4. The whole thing inside the square root. And they ask you to give you an input of x equals at certain values. Well, they tell me that x equals 3. So then I just pop that right in, and it's 3.13. Trying to figure out which of these following choices, because they're in fraction format, which is kind of a bit of annoying. So I'm just going to do a 7 divided by square root of 5 and see what that gives me. Oh, look at that. That gives me the same thing as what I got for the answer. So the answer here is just going to be a. With the calculators, you want to be fluent with how to utilize it to its full benefit, to its full potential, so you can save a lot of time. Number 5, the graph of a differentiable function f is shown above. H of x is equal to the antiderivative of f of t. Now, this is quite tricky because they tell you the derivative function is shown, because the function f, which is right there. Now, if you take the antiderivative of that, it actually becomes h of x. Which of the following is going to be true? And we are looking at the location when x is equal to 6. Now, if you take a notice of f of t, if at x equals 6, the f of t is actually 0, okay? And now we want to be careful about how you want to imagine this right here. H of x is an antiderivative of f of t, which means if I were to take the derivative of h of x and you take the derivative of this, that means the derivative and the antiderivative cancel out. And most likely what happens is the derivative of h actually just becomes f of t. Or actually what you want to do is you want to keep the variables all consistent. So when the derivative is 0, what you want to remember is that this actually gives you a potential of max or min for your regular function h of x. Okay, so when f of t, or your derivative function, is 0, sorry, I'm just going to try to keep this in terms of t just to not confuse you guys, then f of t has either max or min at that location. Okay, so here what happens is the derivative function is negative and then it goes to positive. The function all the way down here is negative and then up here is positive. So that means that the graph is decreasing, then it's increasing afterwards. And so you have a function at x equals 6. This is going to be called a minimum value of f of t of h of 6. Okay, and a minimum value usually consists of the values that is actually kind of low. They are actually going to be in the negative zone. So here, what's going to happen is at h of 6, we want to say that that's pretty much just ending up at, well, the derivative of h of 6 is going to be at 0. Okay. But what happens is when h of 6, that's going to give you the minimum possible value, which usually will kind of tend to go less than 0. And so we want to first look for the fact that h of 6 is going to be less than h prime of 6. Okay, so for example, like a makes sense. I think that's pretty much it here. Yeah, so then it's most likely just going to be a for your final answer. Now, the second derivative of the function, you want to see that this is a derivative function of h of t, or h of x for that matter, or h of t, I'm going to use that. But if you find a tangent line to this, which I'm going to draw, like a tangent line at h of at x equals 6, draw a little bit more bold so you can kind of see a little bit better. So this is a tangent line at x equals 6, or t is equal to 6. Notice how that's a positive slope, which means that when h of double prime 6, that actually becomes positive because your slope, your tangent line at that location is greater than 0. Remember, this curve represents h prime of t. So that means at least the double prime of h has to be bigger than the h prime of 6, which means that, the only thing that really follows that is either c or a, but h of 6, like I told you before, has to give you a minimum. So the answer here is just going to be a for this one. Okay, so this was elaborate. This was quite challenging to do. 15, I would definitely star this one. And if you don't get this, then kind of skip it and move on to the next question. But there it is. Okay. And always good idea to eliminate choices to narrow down your options and get the best possible situation here. Number 16, a particle moves along x-axis with its position at time t, given this function where a and b are constant, where which of the following values of t is a particle at rest? When particle is at rest, your velocity is 0. It stops moving, it stops having its speed. When you have no speed, the particle is at rest. That's what it means. So if I'm given a position function, the derivative of the position function always gives you the velocity function. So I want to find the derivative of t minus a times t minus b. And you want to derive this in terms of t here. The very first thing I kind of want to do for any type of this type of function is make it into a polynomial. So what does that mean? It means to FOIL this out and get every term without any parentheses. That is first t squared minus outer minus inner, and then multiply the last. You get t squared minus at minus bt plus ab. That should be your final function. And you want to derive this in terms of t. So that would mean this will use the power rule 2t and then subtract 1 from the exponent. That's the coefficient, and then plus ab is a constant. So there's not going to be a differentiable, derivative for that one. Remember, that means that this is your velocity function because that's your derivative of your position function. And you want to set this equal to 0. Then all you have to do is, if you look at your answer choices, you want to look at which time gives you the velocity to be 0. So solve for t. Add the a and b on both sides of the equation like this. So you get 2t is equal to a plus b. Divide by 2 on both sides of the equation, so you get t is equal to a plus b over 2. That's your final answer, and that should be the correct answer there as well. All right, number 17, the figure above shows the graph of f. If f of x, this graph is representation of the antiderivative of g of t. Now you got to be really careful though. Whenever they give you this, that means that if I were to derive both of these things, like take the derivative of f of x, that actually gives you g of t, because the antiderivative and the derivative, they will cancel each other out. So this is what you want to remember. So which of the following can be the equation of the graph of g of x? So all that means is if this is the graph of f, the derivative of this graph should be your answer. Notice how this is a singular line. It's a linear function and the slope is positive. So no matter where you go, like remember the derivative in terms of graph is tangent line. So you want to look for tangent lines of this function. Tangent line at that point, well, that looks like that. Tangent line at that point, well, it looks like pretty much consistent with the whatever the slope is going to be. Let's say the slope here, I don't know, slope is like a positive number. I don't know what exact value is, but I know it's going to be positive number. And it's going to be consistent throughout. So whatever the slope is, like for example, if this function is like 2x minus 2, I'm just making up an equation on the spot, then the derivative of this is just simply 2. And it's going to be a straight up flat horizontal, and it's going to be a positive slope. The only answer that gives you that is going to be A. Look at how the derivative or the function for that is just straight up positive number at certain location, and it's consistent throughout of this linear function. And rightfully so. The slope of any linear function should be consistent, and it's going to go like that. All the rest of it doesn't really make that much sense, and B is going to give you a negative slope, so we certainly don't want that there. Okay. All right, and let's see. For number 18, we have limit as h approaches 0 of this crazy looking function. Now, anytime when you see this, your goal is to recognize that, oh, this means that it's one of those f of x plus h minus f of x over h when the derivative, when h is approaching 0. This is same thing as saying the derivative of f of x, because that's the limit definition of the derivative of the function. So whatever this thing says, I tend to kind of focus on whatever that part says right there, which in this example is natural log of 4. And if you were to derive that, you basically get the answer here, okay? So here, it just means that you're trying to take the derivative of a natural log of x and plug x as 4, because that's what it says, afterwards. Remember the special rule that when you're trying to take the derivative of natural log of x, it just becomes 1 over x. And when you plug in 4 into that function, you get 1 over 4 for your final answer there. Okay. All right, and number 19. Number 19 says the function f is defined by that. What points on the graph has the property of the line tangent to? Okay, there's a trigger word right there. Tangent means take the derivative of it once again. That's all it is. Tangent lines to a curve. And has a slope of 1 over 2. So you're looking for when the derivative is equal to 1 over 2 for this particular function. So I'm going to write the function for you guys here, and then we want to find out the derivative of this. This is a function at the top because we have x in the numerator versus also the x in the denominator. This means that we want to use something called a quotient rule, which states that if you're trying to take the derivative of f of x over g of x, you're trying to take the derivative of the first times the second, and you subtract that by, oops, sorry. I think I'm on this page. Yep. And then you're trying to subtract it by taking the derivative of the second times the first. Very similar to the product rule, but you need to remember that I need to take the g of x and then I need to square that whole thing. Okay, so let's do this one at a time. The f of x here is just going to be, oh, I'm sorry, that's going to be x. F prime of x is going to be 1. G of x is x plus 2. And g prime of x is also going to be 1 because you're just trying to look at the slope of these functions here. Very easy. F prime of x is 1, so I'm going to plug that in. 1 times g of x of x plus 2 minus g prime of x of 1 times f of x of x over g of x, which is x plus 2, and you have to square that. Oops, sorry. And there you go. And so what that would give me is x plus 2 minus x over x plus 2 squared. You can cancel out the x's because they kind of, get disappeared. And 2 over x plus 2 squared, that should be your derivative function of f of x. Now the goal is having a slope of 1 over 2 then. So then you want to set the derivative equal to 1/2 and solve for x that actually gives you the solution. This is a fraction equal to a fraction. And whenever you see this, you want to remember that all you got to do is just cross multiply. So then you cross multiplying it that way, which states that x plus 2 squared is equal to a 4. Okay. Now you can square root both sides right away from here, which gives you x plus 2 equals 2. Do not forget that when you're square rooting something, you got to have that plus and minus 2 intact. So when you're solving for this, actually, you will get two solutions, which states x plus 2 is positive 2, and the other solution will be x plus 2 equals a negative 2. Subtract 2 on both sides. For this one, you will get x equals 0. Subtract 2, and you will get x equals negative 4. So you get two solutions for this when x is 0 and x equals negative 4. So the only solution here is going to be C. I'm looking at the x coordinates of these guys here. And the only solution that gives me x equals 0 and x equals negative 4 is answer choice C. And then where is the 0 and positive 2 coming from, you might ask? Well, then I just take that and just plug into the original function. F of x equals x over x plus 2, right? So I can just substitute f of 0. 0 over 0 plus 2 gives me 0, hence 0 comma 0. F of negative 4 over negative 4 plus 2, negative 4 over negative 2, which gives me positive 2 for that one. And hence that's where the y value is coming from. Okay. All right, last question, number 20 for this video. Let f of x be 2x plus 1 to the power of 3 and g be the inverse function of that. Okay, so inverse function means your x and y have been swapped. So if, let's say, for example, I'm going to call this y here. Y is 2x plus 1 to the power of 3. Then you want to swap your y and x location and say x equals 2 times y plus 1 equals 3. Look at how I just swap up the locations of those two, and that's all I did. And then you find what y is. So the first thing you want to do is you want to raise this to the power of 1 over 3 to kind of get rid of the cubic function there. So then the function that you're going to get is x to the power 1/3 is equal to 2y plus 1. subtract the 1, divide by 2, and you would get y is equal to x to the power 1 over 3 minus 1 is divided by 2. And guess what? This is called the inverse function to your original function that they gave you. So given the fact that g of 0 is equal to 1, it says, f of 0 is equal to 1. What is the value of the g prime of 1, it says? So I'm just going to make sure that I label this correctly and say this is the function of g of x, which is your, how would I say, the inverse function of f of x, right? So inverse function of f of x, which is g of x. So now they want you to solve for the g prime of 1. I am going to take this and I'm going to have to derive that in terms of x. So g prime of x is going to equal 2, so I'm going to leave it there. The first thing I want to take a notice of is that if I'm trying to take the derivative of this, I'm going to kind of separate it into a polynomial format instead of seeing this as a whole big fraction. So divide this part by 2 and divide that part by 2. So I want to separate them and say that x to the power 1 over 3 divided by 2 minus 1 over 2. Okay, fair enough. You're just dividing the first function or first term by 2 and the second term by 2. And let's take a derivative of this. So this here means I'm 1/2 times x to the power 1/3 minus 1 over 2. I just kind of try to think of it as multiplied by the coefficient. The power rule states that we're going to bring the exponent to the front, subtract by 1. So that gives me 1 over 6 times x to the power of negative 2 over 3. And the derivative of the constant is always just going to be 0, right? So I don't have to worry about that. So the derivative of g is 1/6 times x to the power of negative 2 over 3. Okay, so then they want you to find the, you just want to plug in 1 into this function here and get 1/6, 1 to the power of negative 2/3. Okay, so then 1 to the power of negative 2/3, if you type it into calculator, 1 to any power is just going to be 1. So there we go. So then all you're left with is 1 over 6. So your final answer here, you're just going to say it's 1 over 6. This part really just serves no purpose. I don't know why they gave you that, actually, to be honest with you, but so you don't have to use it at all. Okay, that was from 11 through 20. Hope this video helped. In the next video, I'll go over from question 21 to the final question of 28. Okay.